In this video, we pay tribute to the brave astronauts who embarked on that fateful mission, exploring the triumphs and challenges of space exploration, and the lessons we've learned from the Challenger disaster. Challenger disaster, explosion of the U.S. Space Shuttle orbiter Challenger, shortly after its launch from Cape Canaveral, Florida, on January 28, 1986, which claimed the lives of 7 astronauts. The primary goal of Shuttle Mission 51L was to launch the second tracking and data relay satellite TDRS-B. It also carried the Spartan Halley spacecraft, a small satellite that was to be released by Challenger and picked up 2 days later after observing Halley's Comet during its closest approach to the Sun. Greatest visibility among the crew went to teacher in space Christa McAuliffe of Concord, New Hampshire, the winner of a national screening begun in 1984. McAuliffe was to conduct at least 2 lessons from orbit and then spend the following 9 months lecturing students across the United States. The goal was to highlight the importance of teachers and to interest students in high-tech careers. Other members of the crew were Commander Francis Dick Scobee, pilot Michael Smith, mission specialists Ellison Onizuka, Judith Resnik, and Ronald McNair, and Hughes Aircraft engineer Gregory Jarvis. The mission experienced trouble at the outset, as the launch was postponed for several days, partly because of delays in getting the previous shuttle mission, 61C Columbia, back on the ground. On the night before the launch, Central Florida was swept by a severe cold wave that deposited thick ice on the launch pad. On launch day, January 28, liftoff was delayed until 11:38 a.m. All appeared to be normal until after the vehicle emerged from max Q, the period of greatest aerodynamic pressure. Mission Control told Scobee, "Challenger, go with throttle up," and seconds later the vehicle disappeared in an explosion just 73 seconds after liftoff, at an altitude of 14,000 meters, 46,000 feet. Tapes salvaged from the wreckage showed that the instant before breakup Smith said, "Uh-oh," but nothing else was heard. Debris rained into the Atlantic Ocean for more than an hour after the explosion. Searches revealed no sign of the crew. The incident immediately grounded the shuttle program. An intensive investigation by the National Aeronautics and Space Administration (NASA) and a commission appointed by U.S. Pres. Ronald Reagan and chaired by former Secretary of State William Rogers followed. Other members of the commission included astronauts Neil Armstrong and Sally Ride, test pilot Chuck Yeager, and physicist Richard Feynman. What emerged was an appalling pattern of assumptions that the vehicle could survive minor mishaps and be pushed even further. The ill-fated launch brought to the fore the difficulties that NASA had been experiencing for many years in trying to accomplish too much with too little money. The immediate cause of the accident was suspected within days and was fully established within a few weeks. The severe cold reduced the resiliency of 2 rubber O-rings that sealed the joint between the 2 lower segments of the right-hand solid rocket booster. At a commission hearing, Feynman convincingly demonstrated the loss of O-ring resiliency by submerging an O-ring in a glass of ice water. Under normal circumstances, when the shuttle's 3 main engines ignited, they pressed the whole vehicle forward, and the boosters were ignited when the vehicle swung back to center. On the morning of the accident, an effect called joint rotation occurred, which prevented the rings from resealing and opened a path for hot exhaust gas to escape from inside the booster. Puffs of black smoke appeared on the far side of the booster in a spot not visible to most cameras. As the vehicle ascended, the leak expanded, and after 59 seconds a 2.4 meters, 8-foot stream of flame emerged from the hole. This grew to 12 meters, 40 feet, and gradually eroded one of 3 struts that secured the booster's base to the large external tank carrying liquid hydrogen and liquid oxygen for the orbiter engines. At the same time, thrust in the booster lagged slightly, although within limits, and the nozzle steering systems tried to compensate. When the strut broke, the booster's base swiveled outward, forcing its nose through the top of the external fuel tank and causing the whole tank to collapse and explode. Through ground tracking cameras this was seen as a brief flame licking from a concealed spot on the right side of the vehicle a few seconds before everything disappeared in the fireball. Even if the plume had been seen at liftoff, there would have been no hope for crew escape, because the shuttle orbiter could not survive high-speed separation from the tank until the last seconds of the booster's 2-minute burn. Challenger broke up in the explosion, but the forward section with the crew cabin was severed in one piece. It continued to coast upward with other debris, including wings and still flaming engines, and then plummeted to the ocean. It was believed that the crew survived the initial breakup but that loss of cabin pressure rendered them unconscious within seconds, since they did not wear pressure suits. Death probably resulted from oxygen deficiency minutes before impact. The boosters also survived the fireball and righted themselves to continue flying, something totally unexpected. Range safety officers finally detonated their charges 30 seconds later to prevent them from overflying land. After the accident, NASA immediately began work on a redesigned solid booster for future launches. An intensive salvage operation was organized to retrieve as much of the wreckage as possible and the bodies of the crew. The task was complicated by the force of the explosion and the altitude at which it occurred, as well as the separate paths taken by the boosters. The Rogers Commission report, delivered on June 6 to the President, faulted NASA as a whole, and its Marshall Space Flight Center in Huntsville, Alabama, and contractor Morton Thiokol, Inc., in Ogden, Utah, in particular, for poor engineering and management. Marshall was responsible for the shuttle boosters, engines, and tank, while Morton Thiokol manufactured the booster motors and assembled them at the Kennedy Space Center at Cape Canaveral, Florida. The Rogers Commission heard disturbing testimony from a number of engineers who had been expressing concern about the reliability of the seals for at least 2 years and who had warned superiors about a possible failure the night before 51L was launched. One of the Rogers Commission's strongest recommendations was to tighten the communication gap between shuttle managers and working engineers. In response to this implied criticism that its quality control measures had become slack, NASA added several more checkpoints in the shuttle bureaucracy, including a new NASA Safety Office and a Shuttle Safety Advisory Panel, in order to prevent such a flawed decision to launch from being made again. Aside from these internal fixes at NASA, however, the Rogers Commission addressed a more fundamental problem. In NASA's efforts to streamline shuttle operations in pursuit of its declared goal of flying 24 missions a year, the Commission said, the agency had simply been pushing too hard. The shuttle program had neither the personnel nor the spare parts to maintain such an ambitious flight rate without straining its physical resources or overworking its technicians. This judgment cut to the core of the way in which the National Space Program had been conducted in the shuttle era. Indeed, the Challenger accident merely focused attention on more deeply seated problems that had existed for as long as 15 years. From the time it was approved by Pres. Richard Nixon in 1972, the shuttle had been conceived as a do-everything vehicle for carrying every kind of space payload, from commercial and scientific satellites to military spacecraft to probes bound for the outer planets. NASA's fleet of conventional, expendable, rockets such as the Delta and Atlas had been phased out in the shuttle era as a result and were being used primarily to reach polar orbits that the shuttle could not reach from Cape Canaveral. Although this reliance on the shuttle was the officially stated national space policy, the Department of Defense had begun to retreat from relying exclusively on the shuttle even before the Challenger accident. Concerned that shuttle launch delays would jeopardize the assured access to space of high-priority national security satellites, the Air Force in 1985 began a program of buying advanced Titan rockets as complementary expendable launch vehicles for its own use. Other, less powerful groups came forward after the Challenger accident to express their long-standing unhappiness with exclusive reliance on the shuttle for their access to space. Among those calling for a mixed fleet of shuttles and expendable launchers were scientists whose missions now faced long delays because the shuttle had become the only existing means of carrying their spacecraft. By July, when NASA announced that the shuttle would not be ready to fly again until 1988, there was still no decision from Congress or the White House as to whether another orbiter would be built to replace Challenger. Proponents argued that another vehicle, perhaps two more, would be needed to meet the launch needs of the 1990s, which would include construction of NASA's International Space Station, a permanent facility in Earth orbit. In mid-August, Pres. Ronald Reagan announced that construction of a replacement shuttle orbiter, later named Endeavour, would begin immediately. When the shuttle resumed service, however, it would no longer be in the business of launching satellites for paying customers but would be devoted almost exclusively to defense and scientific payloads. The Reagan administration had long had the goal of stimulating a private space launch industry, and now, with the removal of a heavily subsidized competitor from the market, 3 different companies stepped forward within a week's time to announce plans for operating commercial versions of the Delta, Titan, and Atlas Centaur launchers. Thank you for joining us on this journey of remembrance and discovery. If you found this video informative, Please like, share, and subscribe to our channel.